Perfect. Welcome to the Perfom Asia podcast. Today we have Oliver Graeser with us from Parcel Perform. Now, what we're going to do today is to understand all things relating to data. So Oliver is a data expert, and of late there are all these terminologies, right? Data lake, data analytics, and even artificial intelligence, how that relates to data. So what we want to do is to dissect the whole data element, right, and ask Oliver questions so we can position data so that anybody will be able to understand. Okay. With that, let me welcome Oliver to the Perfom Asia podcast. Welcome, Oliver.
Thank you for having me.
All right. So let's start off with your background, right? So I noticed I'm looking at your LinkedIn, right? So you've got a doctorate in physics, yes, from CUHK, right? Tell us how that came about.
Oh, I primarily, so physics simply was my undergrad, right? And then I wanted to see the world a bit, and doing a PhD is a really, it's the one easy way, I guess, you can get from Iran to Israel if you want to, because it's a community, it's really, there's not much about borders, easy to get a visa. I looked around, actually back then took a train ride all the way from Germany to Hong Kong, then a plane to Singapore. Stopping along the way, checking out universities. I met my advisor at CUHK. He was very open to the idea, which was a fairly unusual idea there, because I was, for the entire time I was there, I was the only grad student who was not Chinese in the Faculty of Science. I spent 3 amazing years there. I wouldn't want to miss it for the world.
You're going to run through this real fast. You took a train ride from Germany to Hong Kong?
Yes.
How did you do that?
I guess apart from Kiev to Moscow doesn't work that well anymore these days. But Cologne, Berlin, Kiev, Moscow, Irkutsk. Spent a few days at Lake Baikal, which is an absolutely fascinating place. Irkutsk, Beijing, Hangzhou, Hong Kong.
Wow, that's probably
It's a bit of an adventure back then.
A podcast in itself, yeah. Okay, what got you interested in data?
Very bluntly speaking, the first thing I did after graduating was like, okay, how can you make money in a city where basically everything is about commercial transactions, right? I'm a numerate person, I'm a quantitative person, I'm not a person who understands much about money or commerce. So the first instinct was like, okay, who's using mathematical models, right? So quants, investment banking, risk analytics, all these things. That's where I got in. Then I've quickly noticed, hey, what they do is actually very similar to what we even learned in undergrad, right? So half of what I do today is trying to reduce entropy somewhere. That's what you spend 2 years studying in a physics undergrad degree. And then I found it plays to my strength. It's a fairly nice field of work, maybe unlike investment banking from what I've experienced there when I tried to get into that field. And it keeps my mind busy, right? So it's still not bored after years. And of course, the world has also pivoted quite towards AI, machine learning, these things. So there have been always opportunities.
Entropy, what is that?
The degree of unorderedness, right? So basically, what you do want to do in many use cases, just like you want to, let's say, distinguish someone from who will buy a product from someone who will not buy a product, distinguish a parcel that will be late from a parcel that will not be late, distinguish someone who will default from someone who will not be defaulting on a loan, right? If you look at any original population, it's chaos, right? It's like you find all kinds in there. If you can separate them, that is basically what you want to achieve. And the measure for this is this, like, we're getting into formulas then, right? It's entropy. So the less ordered something is, the higher the entropy is. So if you find hypotheses that allow you to separate people from who default from those who don't default, parcels that will be late from those who won't be late, you can measure this entropy is going down, right? And that's basically what you're trying to do. In physics, it's more about temperatures, but the orderedness of like, okay, it's cold over there in the corner, it's hot over here. That means less entropy. In physics, you generally, if you don't touch something, you always know the entropy is going to increase. There's going to be more chaos, but the whole math behind it, all the stuff that is sometimes a bit tough when you get into machine learning, right? It was tough when I was 22 and I had to take statistical mechanics from undergrad, right? But it's something you picked up along the way.
Okay, let me try to understand that. So from a physics perspective, right, entropy essentially says that the world is always going to be in a disorderly state.
It basically says it will always, from any state it's current, any isolated system, from any state it's right now, will either stay completely, if it's completely chaotic, it will stay this way, or it will, if it's not completely chaotic, it will become more chaotic by itself. There is no degree, there's no way that an isolated system by itself can become more orderly, right? You have to make effort. So basically, you have an air conditioner, right? So if you have everywhere the same temperature. Now air conditioning, you switch it on, there it gets cold, here it gets hot. That is more order, you separate this. That costs you energy, which you probably notice at the end of the month on your electricity bill, right? So you need to put the energy in to reduce the chaos. That's the physics side.
Okay, now let's tie this into what you do, right? Parcel Perform, what does the company do?
So the company started basically just trying to give merchant marketplaces a way to basically see what was happening with their shipments, right? Where are they? Which of the carriers has it? Where are problems occurring? We went from there into post-purchase experience, so like updating you where your parcel is as an end consumer. But by now we're trying to say, okay, doing the one-stop solution for any merchant or marketplace that wants to handle everything from the post-purchase experience, the data experience, understanding what will happen. So this is a lot of what I'm working on, which parcels will be late, which parcels will encounter problem, which products you can offer sensibly to consumer who already bought from you. So we use a lot of data and AI, right? But all the way to you want to return something, right? Like for the merchant to use the same solution to trigger the return and maybe to discuss with or to offer the consumer something that they can at least keep the revenue. So like instead of like just, okay, we give you a refund, here's a voucher, we incentivize you in some way to keep the revenue with us.
Okay, let's go through a practical example. So say for example, I use Shopify, yeah, and then I buy something. I buy an iPhone, okay, and then after I buy it, the merchant that actually is in charge of shipping it, they will somehow contact you and say, I've shipped this parcel.
So Shopify can contact us directly.
Yeah.
But with Shopify actually, so we support Shop App. So basically Shop App directly on your phone, they would send us a track number. They wouldn't necessarily know which carrier they shipped it with. Honestly, also because the merchants are not very good at telling Shopify the correct thing. Right? So then it's up to my team to say, okay, which carrier is this with? Is this right now with DHL? Is it with FedEx? Like determining this from the tracking number. We find the parcel there. We poll the carrier. Do you have updates? Has something happened with this? Right? If we find an update, we send it to Shop App, and Shop App will inform you, hey, your parcel is now out for delivery, which is, from a Singapore perspective, probably not a big thing. But if you know the term porch piracy, right, in the US, getting this timely update, hey, today your stuff is going to come, now it's on your front porch, is super, super important, right? Because otherwise you ordered an iPhone and then someone else has that iPhone, right? So it's... It was honestly when I speak to clients in the US who emphasize this importance, from a Singapore perspective, this is quite alien. I go 2 weeks on a holiday and afterwards I come back with all kind of e-commerce orders in front of my door. Nothing has been touched. This is not going to happen in the United States.
I see. So is it fair to think of Parcel Perform as some sort of an app that links together all these different updates from different carriers through APIs, right?
That is the basic product, right? Beyond that is then like, you also want to know when it comes, right? Not only when I say it's out for delivery now, ideally I should tell you 3-4 days before. Ideally, I want to tell you this on the merchant side before you even order something, because what are the criteria that you order something? Yes, in some cases it's purely the price. In some cases you say, hey, only this merchant actually has this thing. Right, but in many cases, if you buy a pair of AirPods, right, it's like, okay, I probably don't want to wait, like even if it's $2 cheaper, I don't want to wait 5 days to get it. Who will get it to me first, right? This is the predictions that we basically offer to the merchants. Hey, you can tell us, like you can use us to show on your website when is the product going to reach the customer.
I see. So since a customer buys something off Amazon or something, right? And then you're able to predict and say it's going to reach you in 5 days' time.
So Amazon does the other way around. We do it for smaller merchants generally. Okay. Amazon does this themselves, but they do it the other way around. Instead of predicting, they control. They basically say, okay, we told that guy is going to come in 2 days. Now we're going to make that happen, whatever way it takes. I had cases where I still don't understand how that made sense for Amazon, but I bought a bicycle trailer for my kids from Amazon SG, which was shipped from Amazon US. And I bought it, and it was not, they said it's coming in 10 days. And for 7 days, it didn't even dispatch. And I was like, hope there's nothing wrong. It was a really good price, right? They offered free shipping. Right?
Yeah. So after that, right? So let's talk about data then, right? So there are many complications and there are many elements in which this can go wrong, right? Could you talk about some of the complications? So what happens if a parcel doesn't go through, or what happens if a customer has some questions that you're not able to answer?
Well, let's say what can happen is like, so what we often talk about, part of our own positioning is like 80-20, right? 80% of the parcel journeys are happy journeys. Everything works exactly as planned. Everyone can handle those, right? 20% is where something goes wrong, and all kind of stuff can go wrong, right? And one of the first things we did was actually, and that's unique to us, no one else in the market does this. So we integrate with more than 1,000 carriers, right? Each of these carriers sends us thousands of different types of events. So we have multiple million of strings that a carrier basically says this is what just happened, right? So we categorize these strings. We actually have our own ontology where we say, okay, here's 130 something different event types, right? Which basically hierarchically distinguish, okay, this actually is ready for pickup. Is it ready for pickup at your own home in a locker? Is it as a parcel locker somewhere in public? Is it at a community locker? Because all those have different implications. So when we get the message from a carrier, the raw string, we have a mapping at the back end that basically says this is this type of event. And if it actually is like, okay, sorry, but someone drove over your parcel with a forklift and you're not getting it, we actually have this as an exception defined. We can inform the consumer, right? Are we the ones who are going to do a refund or send a new item? No, that's the merchant's job to do, but they know right away what happens. And this is the most important thing, because if you look at the scale of operations, right, you always want to find the places that you need to intervene. If you try to look at everything, like your customer service salary, the customer service payroll would be unaffordable. If you just say, no, you'll get it when you get it, you won't have customers anymore. Right? So that's basically where we're looking at. But it's not so much of a data, it's more of a business logic thing.
Got it. Yeah. Now, from a data standpoint, right? Let's go straight down to the nitty-gritty stuff, right? Data. We hear of all these terminologies, right? Data lake is one of them, right? And then the data analytics, right? Could you paint a picture as to raw data and when it becomes information, right? What is the flow like?
So basically, for us, we're kind of the mass manufacturing equivalent of data, because we poll for like millions of parcels every day, all the carriers repeatedly, hey, do you have an update? We use so there's basically data streaming technologies. This is purely only part of the engineering team. There's no analytics or no insight in there. It's just like, okay, we need to process all these incoming events. We need to categorize them. We need to store them in our database. We use primarily, our systems are based on Kafka and Flink. Those are like big queuing and stream processing frameworks. That at that point, it's just like, okay, making sure the application works. Any of our clients can look up what's going on with the parcel. We send out notifications, all these things. That kind of, if you so want, that stops at the database. Database in this case, meaning like the transaction processing. So something has just happened. We know what it is. Please update the status of this parcel and so on. For analytics, it's basically the question, okay, how do you make sense, or more importantly, how do you take this and find ways to operationalize insight in this operational queue for the users? So you don't want, ideally, not having a data scientist or a data analyst mess with production systems. So what typically you have is a data warehouse. We also have one, but we primarily rely on our data lake, simply due to the scale, where we basically, all the data that we process gets stored. And we're basically having different projects. For example, as I mentioned before, predictions, right? So our predictions generally, every of our customers gets their own dedicated models. So basically, we look at their data, we pull from the data, we look at where do you ship from, where do you ship to, what carriers do you use, what metrics do we want to create around this. We build our machine learning models. This is all like without affecting production anyway. And then when we have that model artifact built, that would tell you, hey, for a parcel at this stage in the journey, it will with 85% probability reach you tomorrow. That we hand back over to data engineering, who basically puts this into the stream processing flow. So whenever this parcel gets updated from the carrier side, we can say, okay, does that change anything about our predictions? And if we actually say, hey, oh yeah, the carrier just like the parcel went into this warehouse and hasn't come out for 3 days, and that should really not happening. We need to update our prediction. We need to update the consumer. We need to update the merchants because what you don't want to do, a lot of carriers actually do, unfortunately, is like sending you an update that says like your parcel's coming tomorrow. I know, now it's coming, like the next day it says, now it's coming tomorrow. Now it's coming tomorrow, right? It's like we always like, hey, you're just pushing it out. You don't get any information. For us, it's important to always really give a reliable estimate, right? And so we model it, put it back, operationalize it, and make sure you get a very, very timely update when actually something happens.
What's the difference, right, between, say, a data warehouse and a data lake?
Okay, primarily, it depends a little bit on who I am. If I'm someone who tries to use it or someone who tries to sell you one, right? But the fundamental thing that has happened in the last 15 years was, okay, we have a latency versus bandwidth trade-off. So latency is how fast you get something finished, or a small task finished. Bandwidth, how fast you get something really, really big processed, right? So traditional database, you do something like you transfer money, you buy something online, you want that transaction to be done within a second. You don't want to wait like 3 minutes till your merchant says, yes, you actually bought this. So that's important with latency, that's databases. For analytics, we always care more about bandwidth, right? It's okay if something more complex query runs 15 minutes or so, but I don't want to restrict myself to looking at your data. I want to look at, like, we have billions of events in our system coming new in every month. I want to look at all of them. I want to actually say, okay, show me for all carriers in the last month what was their on-time performance based on their own initial promise, right? And I need to crunch through millions of records. The first step to do this was basically a data warehouse, something that was more tailored towards, you process a big chunk of data in big batches. Then I think you asked me before once about Hadoop, right? Then came technologies like Hadoop that says, hey, can we not use like a single box that's always there, always has the same capacity, always costs the same money? Can we use cheaper boxes, like off-the-shelf computers across which we distribute it? Right, that was the first step. Now the data lake concept is basically trying to separate this completely. Here you have, on the one hand, you have super cheap storage, Amazon S3. Our data lake sits on S3. You get it also on blob storage, equivalent, Google, whatever. Right? And the data is just there and it's cheap, right? Retaining terabytes of data does not cost much money. If I don't do anything right now, tech team is based in Asia, right? So in the middle of the night in Asia, nothing's happening in terms of manual and big analytics. I don't pay anything more than just storing. If I had a data warehouse, I'd still pay for the box. Or I either pay once up front to have my own box, or I pay all the time, yes, this is my data warehouse. Right? If I then want to run a query, if I want to do a big analysis, Amazon basically throws everything and the kitchen sink at the computation thereof. So I have no problem with Athena or with other tech. This is like most vendors have something like this, right? To crunch through several terabytes of data, just say, okay, tell me, like, classic questions really for all my carriers that I'm looking at, show me what was for each parcel the first time they said this is when you get it, and what was actually the on-time, how often did they actually meet this promise, right? And I need to go through all parcels that I had. I need to look at every time I checked on the carrier side when they made the promise for the first time, because it can vary widely. And then I need to aggregate this, and I get all the compute power that I need, and I pay only for this one task, right? And that makes a lot more sense. Generally, it's more efficient because I don't need to compute. Amazon can put it elsewhere. It's a more efficient way for a cloud vendor to operate, but it also makes a lot of sense for us that I don't have to restrict myself, right? I never get a situation where I have 5 analysts trying to get something out of a Redshift instance, and like the instance, like, yeah, sorry, I'm overloaded. I wanna stop, right? We still keep data warehouses still can keep smaller aggregations much faster, so we still retain an instance primarily for our own clients to do their BI on, right? Pre-aggregated queries. It has its use case, but if you really want to know, if you want to dig deep, data lake is just a lot nicer.
I see. The data warehouse, irrespective of whether you're using the data or not, you got to pay for it.
A data warehouse is a box. It's really it's a server. On a server runs a software, right? The a data lake is purest form. It's just storage. It's just storage, like the same way you like have funny cat pictures on Imgur, right? It's just like naked storage by itself. There are a few other things. So if I try to sell you one, I will talk a lot about like, oh, you don't need to define a schema. You can just dump your data there. You don't even need to know what it is by the time you store it. You can define this later when you try to analyze it. Which is like you're basically kicking the can down the road into a sales argument. I don't have a very high opinion of that approach, but there's a few other such things. But the general, like completely separating compute, having compute completely on demand, having just storage there otherwise, and having the cheap kind of storage, not the attached disk, but the network connected kind of storage, is what makes it a lot more powerful. Like you get a lot more bang for the buck for the type of heavy insight generation that we do.
I see. And when someone says big data, right, do they essentially mean lots of data?
You need to ask them that. No one properly defined that ever. Like this was one of these. So big data came up in the context of Hadoop, and I think what people meant by then was like stuff that you can't really process on a single machine at the time. Right? This was more buzzword from like 15 years ago. The other thing that was often associated with it was like, because the only type of supplement would be log message, or if I track your mouse when you're browsing Netflix or stuff like that, like that it was this kind of semi-structured message where you actually need to filter each message to see what's in there. Is this the type of message I want to see? My opinion was a very poorly chosen word, right? Because you go into something with a use case, you see someone has something that could qualify for big data, you have a solution that can deal with big data, you put both together and see it absolutely doesn't fit. It was a huge boon for the likes of Accenture and Co. because they sold tons of Hadoop big data projects. In my opinion, wasn't very impactful, right? It's a term that has fallen out, right? Nowadays, you would a lot more talk about document-based data, streaming data, relational data, and then you just quantify, so we stream log records about 3 terabytes per day, right? That's a lot more, it's not quite as snazzy, but it makes very clear what problem you have, what you want to do, and there's much more refined tooling for it, right? So different kind of use cases, you get the right tool when you're a bit more specific.
You touched upon this before, right? So Hadoop, is it like an SQL thing for querying large amounts of data? What exactly is it?
Hadoop is a technology SQL is my favorite paper. So SQL is actually really cool because it's one of the few declarative programming languages that you that people come in touch with regularly, which means all you do is you define a problem. You actually don't tell the computer what to do. All you say is like, hey, I want data that follows these rules. And what happens under the hood is something turns it into instructions how to give you the data. Hadoop is one way of basically turning such a declarative problem statement into work that is then not run on a single machine, but where basically lots of individual computers get their own piece of work, crunch this through, send it back to or share it, and then say, okay, let's put all our results together and condense it into what's needed.
Sorry, what does declarative mean?
Declarative means the general primary paradigm, I think, is declarative versus imperative, right? Declarative means I tell you what the output should be, find a way to do it, right? I define the problem, the computer finds a step to the solution. Imperative means I tell the computer exactly what steps to follow. So typical thing for a database is actually you have a query planner that actually looks at your declaration of the problem, what is the data that you want, and turns it into steps and say, okay, do a full table scan of this table, join it via a hash join to that table. That's imperative. So, but the orders, basically what steps to follow, are coming from a program itself. The user just does this is the type of data I want to see, right? So SQL is the most common type of language where an end user uses this declarative paradigm. I personally really like it. Was for me back then when I first learned about it. I was like, hey, this makes actually a lot of sense, right? But Hadoop is just one of the many technologies. Hadoop was probably not the first one, but the first widespread adopted one that had allowed you to define a problem and it turned it into instruction to distribute this massively, right? Nowadays, I honestly don't see it used much anymore. It's just like this. For the same kind of use case, Spark that solved a lot of problems that Hadoop had. But there are, like as I said, we're using on our data lake, we're basically getting, I have no idea what Amazon does when it distributes stuff on Athena, right? But no, by and large, it works, and I can see exactly how much we're spending, and it's very easy, right? So technology has moved on a bit, right?
I'm going to try and understand this, right? So basically, so if I say there is a school progress report data, right, sitting on a SQL database somewhere. So if I were to go as an end user and say select star from the class 12 results and I get a table, that's essentially an SQL statement querying one database, right? Whereas a Hadoop is a system where that sort of a database sits on many different computers and
it's not really a database. In many cases, you just imagine it as a blank file, right? You basically say, okay, every computer has its own slice, like a text file where it says like a CSV file maybe, right? Where it would honestly don't know how too much about Hadoop, but with a data lake, that's how it works. You can just distribute. Here's a bit of a CSV file. There's another, or you use a Parquet file. There's different structured files, and then you just say, okay, what do I need? Let's say you have a filter. Like, give me everyone born in 1979, right? Then every computer can for itself say, okay, for the records that I have, can I pull out those from 1979? Okay, I can do this, right? Send it back to a central node, put them all together, right? And but the fact that you don't have as a programmer or as a data analyst in particular, no data analyst would be able to come up with an algorithm to distribute work, right? It's just something you're not trained to do. This is fairly deep algorithms. That's like usually the course algorithms, data structures. It's a course where computer science students decide to leave if they're not finishing, right? Like, so this Hadoop is a technology that basically abstracts this largely. It was the first technology that abstracted that largely away and left you just to define what kind of data do I want to get back. Because all you have to know is, like, logically, I have a lot of user records. They all have this attribute. I want to be filtered for this attribute.
Got it. Relational database, I guess we all know this is related to that, right? When would one need a non-relational database?
So it's a good question, because I personally don't need it too much. But it's actually, from my perspective, where I see it having the biggest impact is actually from a very odd point of view in terms of engineering empowerment. So if you think about, let's say, financial institution, all the entities they're dealing with, financial transactions, payments, there's actually not that many of them. I mean, there's many transactions, but there's not that many entities. So putting them in a relation is fairly simple. Now, when we started seeing Web 2.0, which was like a social web, Facebook, Twitter, and so on, there was suddenly a lot more variety, right? And if you want to map, you can still go and find a way to take all these objects that you're dealing with as a programmer. Object is what they think of first, typically, to map them into a database. There are, like, it's called an ORM, object relational mapping. Exists for this, but it's honestly, it's fairly heavy lifting mentally, right? You like making sure you create sane structures in your database to cover all I mean, just think about what you post or what things you have on Facebook, right? It becomes very, very complex already. And I think the standard non-SQL database is a document database where you just say, okay, look, I have one document that in typically a JSON or an XML format has information about you, right? It could just have a section where it lists all your runs. Other people don't run. Could have a section with that deal with your cats. Every time you want to go, actually, someone goes to your page, all the information about you it's easy to retrieve. You don't need to retrieve a giant relational schema. You just retrieve the document for you. It's there. It reduces, so my experience has been, it reduces the cognitive overhead on a developer massively and makes them a lot more independent, because if they go and say, okay, we want to support cat pictures in our app, right? Adding cats to that document as a section, okay, cats you own as a section under you, right? super easy to add. Like they don't need to speak to the database admin. They don't need to define indices. There's cats now, right? And that generally helps a lot with more complex data structures that are not static, and they're where you would say like we're both people, right? But the thing that we would probably put into a document about us is vastly different, right? There's a few things you work in recruitment, few things that goes on everyone's CV, right? But the moment you go into private stuff, like there is like so, someone will say, no, of course I want to have all my music in my profile, like back in MySpace. That's what people put there, right? And other people would say, of course I'm in Strava, I want to have all these runs, and so. If you want to have the ability to easily add this, it's a relational database makes it quite hard.
I see. Is every non-relational database a document database?
No.
It's not.
I would not pretend that I know how many even are out there. Like document is one. Another one is a key value store where you basically is Redis is a very popular thing, like to cache things quickly to basically say, okay, I need to. I basically figured out, okay, the section I want to display on a web page is about this person, about this event or whatsoever. I want to quickly just retrieve all that information. So a key value store, there are, I'm not sure if you would even call a vector database a relational database or not. Not sure how they figured that out. But there's lots of other types. But I think the one that's the easiest to understand, there's graph databases, right, which is yet another thing. The one that's easiest to understand, okay, why do you need something else than SQL, is the document database, because like just the visualization of this, you can make it an everyday problem, right? Just try to write down for yourself how you would structure all your life information in tables, and the number of tables, if you just say, okay, I want to write one document about me, it's a lot easier.
Got it. You mentioned JSON and XML, right? XML, I understand, it's a bunch of tags to describe whatever, right? What's the difference between a JSON result and an XML result?
XML is for people who like backslashes. JSON's for people who like curly brackets. So in the end, it's the same. I'm not sure if you can actually describe something in one of them that can't be described in the other. But in the end, it boils down to the same thing, right? So it's just a different syntactic way of providing a certain object notation. XML came basically out of SGML towards the start of Web 2.0. JSON JavaScript object notation does the same thing, but it's syntactically very close to JavaScript, and I personally also find it a little bit easier to read, right? But if you were someone who was very used to HTML, you would probably say the same thing about XML. Like this, in day-to-day, you could basically use both.
SQL, we kind of know now. No SQL. So is everything that's not SQL no SQL, or how does that work?
Yeah. Another word like big data that no one ever should have come up with. Yeah, it's honestly no. This is one of the things that I think they probably coined it again when they said how they're going to use document databases differently to relational databases. But then NoSQL quickly proliferated because there's other ways to build data stores, databases that don't use SQL, and in the end, it is something where it really doesn't mean much anymore, except that like no, we're not talking about a relational database. But by itself, someone tells me, yeah, we're using NoSQL database. Yes, like you don't say. It's like it's like you ask how the weather is, and you say there is no hurricane right now. It's like that's helpful.
Got it. Kafka, what's that?
Kafka is a streaming framework. So basically, say when you work in any kind of IT infrastructure, there's two ways that primarily data get exchanged. One is a RESTful API call where I basically say, hey, I want this from you, and then you give it back, give me an answer back. And the other way is just like, look, I want you always to do the same thing with those things that I give you here, right? So for example, all our events that come in, as I said before, we map them, we figure out exactly what they mean. So we basically say every event gets packaged actually as a JSON message with what we have retrieved originally, and someone has to crunch through it. So we put it onto Kafka topic. Right, so it's a queue where like we push everything in here. At the other end, so it's a Flink processor who pulls one after the other from there. It's generally it's a fairly nice way, in my opinion, of also of as a mental model when you process a lot of data, because you can, for example, you could just say, hey, how much backlog do we have right now? You just look how much messages I might use. We can make easy triggers to scale. This is all a bit more tricky when you have a standard web service. And Kafka, I would say, is probably the predominant open source technology for like such a messaging framework, streaming framework.
Got it. Now I want to move on to analytics, right? So we hear terms like predictive analytics, right? My question is, what is the difference between predictive analytics and AI?
Okay, AI is a third word that no one should ever have used, right? So predictive analytics is primarily, so analytics per se, insights from data. Descriptive, you describe what's there. Predictive, you're basically saying, okay, I believe this is what's going to happen next, which is typically solved as, in most cases, being solved as a supervised machine learning problem, right? You basically say, okay, in the past I saw, I had a bunch of, let's say, hundreds of millions of parcels. I can say which of them arrived after 2 days, which of them arrived after 3 days. I've trained a machine learning algorithm to determine what were the influencing factors. It will make such a prediction. AI, look, when I did my first, I did once a Udacity course in AI, and what it taught me was a star search, which is the way that Google Maps tells you when you say, I want to go from here to Geelong, what's the fastest way? That's a star search. No one would call this AI today. And why is AI such a horrible word? Because no one actually ever came up with a proper definition of intelligence. If you go back 100 years, you'd probably say, okay, someone who can multiply and divide numbers very quickly is very smart. Right? By that definition, the very first computer was smarter than all humans. Right? Peter Norwick, who's a big shot at Google, he defined AI as basically, okay, everything that we don't understand how a computer is currently doing it. And what we're currently seeing as AI being tossed around is largely around the interaction using human language, because we never expected a computer to be able to do that so easily. Right? What lots of people don't know, so what we have right now, the primary AI things is generative AI, either large language models, so models where you basically can send language in, you get an answer out, or diffusion models that basically can create images or stuff, or even videos from a description. The latter I'm not really an expert on, so I can't exactly explain how they work. The former, however, is quite simple. Actually, what's happened under the hood is pure predictive analytics, because what an LLM does is it builds it takes a humongous corpus of text, and then it builds a machine learning model that says, okay, I look at all the text that happened in the past, and I make a prediction what is going to be the next word. And then I have when I look at all this together, and I predict another one. Now, the algorithms of those, they have evolved a lot in the last 10 years. And of course, the results are absolutely amazing. But what happens under the hood is predict a new token, put all the thing back in my model, predict the next token. This is why ChatGPT 4.0 is so, when you see it appearing bit by bit on the screen, this is not an animation. This is actually how it works. And this is actually how slow it processes, right? So I would say nowadays, in terms of work-wise, predictive analytics, people typically think about, okay, going to predict either a number or a class or an event based on tabular data, right? Because this is something where they also often work themselves to figure out what features to use, what algorithm to use, how to tune the algorithm. So there's a different skill set. Whereas LLMs, right? The architectures of those has gone so humongous that you basically have 50 companies on the globe who will really have the money to toss it at these problems, right? Foremost, of course, Google, OpenAI, Facebook, with FAIR being very prominent, and who have the resources to acquire the humongous text corpus that you need for this, right? And the way you use it is actually as a box where you just send the text in and you get new text out, right? So there is, well, I would still say lots of people working in Gen AI, they probably follow what has been built inside to just sometimes understand why are some things hallucinating more or less or stuff like that. But there's very few people who directly build something like that up from the ground like this. It's a very, very narrow discipline by now. Right?
Yeah. Here's my question, right? So say even ChatGPT, right? Essentially, I don't know how, some vector database or whatever, it predicts what's going to come next, right? Isn't that the same as predictive analytics then?
No, it is. You don't see it this way, right? I mean, if you go to the website and you say, hey, ChatGPT, give me a recipe for gingerbread, you don't see that this is happening. But this is like when, for people who a little bit understand where this is also coming from, right? So, I mean, the big jump happened in 2015 when Google released TensorFlow. Back then, you could still build some smaller language models. We had some back then when I was a jobbable in production that we built all by ourselves. When you look at this, you're like, no, there is never going to be anything like a generalized artificial general intelligence coming out of this, right? This is it's one tool. The only thing that makes it so incredibly impressive is that we have always associated like being able to answer with expert level knowledge and confidence on a verbal question. We've always associated that with high intelligence. So therefore it appears to us as to be intelligence, but in fact, it's just matrix multiplication. Right? I don't want to diminish this to the slightest, right? I mean, the amount of productivity gains that we got from there, the amount of enablement we've seen is nothing short of amazing. But let's keep in mind, the moment when we suddenly had computers who could just do accounting and add up columns of numbers, right, that was also amazing. Like, you don't want to go back to doing your accounting with someone actually going through the ledger and manually adding up all the digits, right? So it's like there is nothing that you would generally, from a purely human perspective, in terms of cognition, consider intelligence is happening there.
Wow, fascinating, yeah. Let's a couple of questions before we finish. One is, where do you see all this going? So, I mean, data, AI, what do you think future technologists should be prepared for? Say someone doing their computer engineering right now, well, what do you think is going to happen to their careers in the next 2-3 years?
Or... Oh, they're going to be just fine. Look, a lot of people are saying, oh, ChatGPT can write code for me. So computer science students would need to worry. If I look at our engineers for problems they're trying to crack, it's not about code, right? It's never about writing right code. It's about the architecture. Recently we had discussion internally where we were worried about something. What was it called? Multi-sect, like something basically where your database runs out of a certain type of ID. Ask ChatGPT that. They have no clue. You actually have to think about what could it mean, what would it mean. Anyone who studies computer science will be fine. Right? What's important is you need to stay on top of the game. If you start doing any kind of work where you basically... I started my career in consulting, right? One thing that people liked me as a junior consultant on their project was I knew how to write SQL and knew how to write VBA. I could whip up a small Excel tool with a form and click and whatnot very, very quickly, right? People paid good money for this. I could have just you probably can still make this money today, but at some point this easy stuff is going to run out, right? So you need to, I think everyone needs to focus on, okay, like let's always use the new technologies to improve my own abilities. But there's no chance that someone who actually now graduates computer science at NUS would find like, hey, my job has been replaced with AI. It's not going to happen. Not in the next 10 years. Like, I'm very curious to see where the journey is going with AI. There are a few people, very prominent people with impeccable academic credentials, a history like Jan Latsum, who basically came up with the underlying quant nets that still power much of what we're currently using, who's like, no, AGI will work differently. I haven't heard him saying actually how it will work. Like the thing is, we basically figured out one model with these large language models that gives us so many benefits that I don't see that much happening right now elsewhere. I'm very curious, but we also have to realize the reason it's so successful is because the internet has provided an insane amount of training data through these models. Where would you get anything remote like that if it's not just text? Like, well, where would you get something that actually helps about making decisions? So, yeah, I have a pretty big question mark there myself. I see a bunch of hurdles on the horizon because obviously when people saw how much money there's and suddenly flowing around, right, everyone gets a bit jealous. You could say, okay, like, is it okay for any of these companies to use Stack Overflow, to use Reddit, which is where they get a lot of their high quality trading data from? Now, these companies will want to have their slice of that, right? I'm sure they all have lawyers who will, in some shape or form, try to tell other companies you're not allowed to use this. This is our IP, right? GitHub, right? A lot of the code that's publicly visible. If your code is my personal code for some pet projects on GitHub, should OpenAI be allowed to use this? There's going to be a lot of open questions where someone in the past just printed ahead and it gave us amazing results. Is this going to be quite that easy? I'm not sure. I'm honestly not sure.
So you don't think, like Elon Musk says, right? Robots are gonna kill humans or whatever. Take over the world. Humanity is gonna end. So
I once had very, very deep admiration for Elon Musk, but he has been, I think, maybe my brain is too weak to comprehend his genius. But he has done very few things in the last 3-4 years where I would say they make any sense at all. So no, and I look. If I'm afraid of anything, it's the climate zones of the planet changing in a way that makes it uninhabitable in places where a lot of people live, because that is truly dangerous. Machines, like there is. We can carry this very quickly into a philosophical discussion by asking you, hey, what makes you sure I'm not a machine?
Wow, I'm not 100% sure. It could be, and I could be too. So.
No, so you should know about yourself that you're not, because you have your own consciousness. And I know for myself I have consciousness, therefore I'm not a machine, but I can't know this for sure about you, because all I do is like I observe you from the outside, and therefore I can't be sure, like I could at some point be a machine that behaves exactly like Vince behaves. Yes, absolutely. Would that make that machine then in any form intelligent? Not necessarily, because imitating, like just if we at some point have complete cameras around us for our entire life and using this as training data to train a system to behave exactly like a human, yes, that's entirely possible. That would still not be intelligence, right? So, and especially there is I think for every human, there are underlying motivating desires. You can program those into a computer, like optimize for something. Maybe at some point, maybe Li Ka-shing is a robot who's optimized for earning money. I don't know. Maybe Elon Musk is. Maybe he's running out of batteries. But I like the core thing that you say, okay, I have a self-interest that does not come from the outside. Not with anything we currently even are envisioning, because as I said, it's all matrix multiplication. It's matrix multiplication plus a certain amount of random number generation. If you go into your ChatGPT interface, there's something called temperature. That changes the impact of the random number. Otherwise, it's just like if you turn this to 0, put the same thing 10 times in, you get 10 times the same result. Which human would do this? None.
Fascinating conversation. Oliver, where can our audience learn more about you?
About me? Geez, I'm still trying to figure some stuff out about myself. So I'm not sure there's that much more for other people to learn. Yeah, you didn't give me that question beforehand. No, it's like maybe the fact, there's going to be a good end for this, right? I'm one of the few people who remembers how you were standing outside of Chengong Center with a sign asking Li Ka-shing to tell you how to make money. So, and I, like, those are the things, like, if there's something about me, I find such stuff always incredibly intriguing and memorable, because there is just, The world is way too normal, and I'm personally just always a huge fan of anything that makes it extraordinary in ways that I don't understand.
Thank you very much, Oliver. Great chat. Thank you.